In this lecture, we're going to talk about the concepts of inheritance and polymorphism. This lecture will be followed up with another lecture that demonstrates how these concepts are implemented in code, and specifically how they're implemented in Java. So let's go to Wikipedia for a definition of inheritance. Inheritance is a way to form new classes using classes that have already been defined. The new classes inherit attributes and behavior of the pre-existing classes. What does this come down to? What does this mean? Well, let's expand on that. Inheritance gives us the ability to reuse existing code by having one class take on the behaviors and properties of another. It allows the code within a given project to be a little bit more flexible. A lot of times you'll see people discuss inheritance and the ability to reuse code across different projects, but that can often be a pretty hefty task and be more expensive in terms of development time than really trying to implement flexibility and reuse within a given project. So we really want to think about flexibility within a project, not necessarily within, say, a company for multiple projects. But that might be something that you want to do as well to save development time. So really, though, I'm talking about tightly scoped reuse. Now, the other thing that's really important about inheritance is that it allows us to take related concepts and organize them in a logical manner. You've noticed that there are a lot of connections between the ideas of object-oriented coding and ideas between how objects relate to each other in the real world. This is another one of those instances. So we get this idea of organization, again, which is very important, organizing our code. And again, that organization can be for logical means, or it can be for the ability to reuse code at a later date. So what's really cool is we're going to have this idea of abstracting out or organizing code so that we can have common behaviors and properties stored in a single class that we'll call a parent class or a superclass, and then we can have other classes take on or reuse that code. So you as a programmer don't need to rewrite that code. One quick mention of Java, though, in this lecture is that Java, like a bunch of other classes or other programming languages, only supports what's called single inheritance. In other words, any given class can only have one parent class. Okay? So that's one of the things that we need to discuss as we look at this concept. So think about this idea. When you implement inheritance, you're taking this idea of abstracting out the common functionality and common attributes of a specifically logically related set of objects. So, for example, if we look at the idea of a car and a truck, we know that these are both vehicles. Well, what makes something a vehicle? Well, it's got an engine, it's got a steering wheel, gas pedal, brake pedal, four wheels, maybe, in most cases. So really, when we look at a vehicle is an abstract concept. A car is a specific type of vehicle. A truck is a specific type of vehicle. We can look at the common traits of car and truck, and we can abstract them out into a class called vehicle, which that means we don't need to rewrite the same code in both car and truck. We can write it one time in vehicle and let the code in car and truck basically just inherit from vehicle. Early on in our lecture, we looked at this idea of a cat and a dog. Not in the lecture, I'm sorry. Earlier on in the class, we looked at this concept of a cat and a dog, and we started to realize that cats and dogs have a lot of the same attributes and perform a lot of the same behaviors. Well, instead of having to write all of those behaviors twice and maintain them in two spots for both cats and dogs, inheritance gives us the ability to move those common behaviors and common properties up into a class, say, called animal, and then we could just write cat-like things in the cat class and dog-like things in the dog class and let the animal class stand as a way to reuse code. Another thing that's really important, you might have this idea of a publication. Well, a book is a type of publication, so is a magazine, so is a newspaper, you could even call a website a publication. So there are some things that are also abstracted at that level as well, and then more specific in the book. And notice that inheritance has this concept of abstract concepts related to more specific concepts. So we put the concepts that are general into the parent class, and then as we start to work our way down an inheritance hierarchy, what we do is we specify. And again, we have this idea of a baseball player. A pitcher is a specific type of baseball player. A catcher is a specific type of baseball player. So, abstract to more specific. What does this look like in UML? Well, we have this idea of inheritance being represented by a solid triangle with a solid line. So, on the right-hand side of this lecture is a correct inheritance hierarchy in Java. Notice that I have a class called vehicle. Okay, vehicle is the parent class for this entire hierarchy on the right. And you'll notice that beneath that is the class automobile. An automobile is a specific extension of vehicle. Maybe we could have bicycle, right? And that's really, really convenient. But in this case, I've chosen to have automobile. So vehicle is my generic set of properties and behaviors. I've specified that further by going into an automobile class. And then finally, I've gone to a specific type of automobile called a truck. So I could also write a car down at this level as well that could feed off of automobile. And if I wanted to maybe make a bicycle class, I could extend directly from vehicle. So this is what an inheritance hierarchy looks like. Okay, we start with abstract concepts at the top, and we get more specific as we go down, and we get as specific as we want to get as we navigate down the inheritance hierarchy. And this is the same thing if, it's the same concept if you've taken a biology class and you've looked at the kingdom, phylum, hierarchy of organization of living organisms within biology. It's the same kind of concept. Let's go over to the one on the right. Notice here I have a parent class, and I have this concept of an employee, whatever an employee means. So there are generic things, even if you're the CEO of a company, you are technically an employee of that company. So if we look at the employee class, we notice that I can actually reuse these employee traits in two cases. Okay, I have a child class and a parent class relationship, a subclass and a superclass relationship. Notice here on the left I've got a manager, and a manager is an employee, and so this manager has a bunch of things that they can do. Maybe they can unlock the store, take money to the bank, stuff like that. But they are still an employee, so they still get benefits, they still get a paycheck. Maybe those are the types of components that I have in the parent class. Over here I have a cashier. A cashier's job is to just, maybe in this instance, check things out and, provide customer service. So I've gone ahead and I have extended employee as well, because they still get a paycheck themselves, and they still have, maybe benefits or whatever. So this idea that I can have one common class that can be extended by other classes. In other words, I can have them take on the properties and behaviors. And it's nice because I only have to rewrite these employee behaviors one time. I only have to rewrite these vehicle behaviors one time. I only have to write these automobile behaviors one time. And then I can go ahead and I get all of those behaviors and functionality through inheritance. I inherit those behaviors. Just like you might inherit blue eyes from a parent, in this case, you are inheriting the behaviors and properties of other objects that you extend. Notice in all of these instances that every child class only has one parent class. So unlike human biology, where every human has two parents, biologically speaking, in Java, every child class can only have a single parent class. Okay, so it's single inheritance. Notice, a child has one parent. A child has one parent. If you want multiple parents, you can have a hierarchy of singly inherited classes. So, inheritance creates an is-a relationship. So anytime you build an inheritance relationship, we want to go ahead and we want to ask these questions. Say, is this object a version of the other object? And more specifically, is this a specialization of the parent class? So if we ask a question of, is a manager a type of employee? Why, yes, a manager is an employee. Is a pediatrician a type of doctor? Yes, a pediatrician is a type of doctor. So let's go back up to the previous slide and just kind of ask these questions again. Is an automobile a type of vehicle? Sure. I guess I'm using vehicle in the sense of anything that moves you forward, maybe a skateboard and a bike. Is a truck a type of automobile? It is. In fact, we can double check and say, is a truck a type of vehicle? Yeah, it is. But we can't go the other direction, right? Notice we're going up the tree. We're going from specialized to generalized. Is a vehicle a truck? In other words, are all vehicles trucks? No, but all trucks are vehicles, correct? And all trucks are automobiles, correct? But not all automobiles are trucks. So notice the arrows point up in a specific fashion to tell us and check this is a relationship concept. Also notice, by the way, it's assumed, but just to point it out, that we represent in UML a inheritance relationship with a solid triangle with a solid line. And again, in our case tool, you'll see that it's really easy to implement that. So if the answer is yes, you are probably on the right track. Notice you say, well, employees do certain things, so maybe you want to steal some of that functionality for, say, like a customer. Well, is a customer a type of employee? Maybe if you work for the company, but that's not a good generalization, right? customers are not employees, right? A manager is an employee, but a customer is not an employee, so we would never inherit a customer class from an employee class. So make sure that you can ask that question. Is my child class a type of my parent class? Is the generalization, is the specialization a type of the generalization? So let's talk about this. Let's say we take a human and we extend that human with police powers. So now we have a human class, and we've gone ahead and we have extended the human class with specifics that make that human being a police officer. Okay? So we've extended the capabilities. All we've done in this class for police officer is we've added onto the general traits of a human being. You know, things like run, talk, think logically, drive a car. Maybe those are things that a human being can do. Then down here in our police officer class, we've generalized more. We've said things like think logically in a legal manner, drive a car in a way that is high performance for chases, you know, properly, operate a firearm, properly utilize judgment in applying force, stuff like that. Okay, so specific things that are related to a police officer. Let's say we want to go one step further and extend our police officer with super robotic skills. Right? So now we've taken everything that is a police officer and we've added on the RoboCop-like features. So now we have, this super cop, and we've been able to extend the police officer's abilities with, robotic capabilities that give them superpowers and super abilities. So let's do the test. Okay, is a police officer a human being? Yeah, that sounds good. A police officer is a human being. Is RoboCop a police officer? Yes, RoboCop is a police officer. Is RoboCop a human being? Yeah, somewhere under there, he is a human being. Is a human being a RoboCop? Like, are all human beings RoboCops if we go down the tree? No, there's only one RoboCop, right? So we've got, we can't necessarily make that specification there. So you only go up. RoboCop is a police officer. RoboCop is a human being. A police officer is a human being. A human being is a human being, right? But we can't necessarily go the opposite direction. All right, this is the concept of inheritance. I think the RoboCop demonstration is the best way to remember it, but you may disagree. Let's now talk about a concept called polymorphism. Once we get this idea that one object is another object, we get into this powerful process in object-oriented code called polymorphism. And simply, it just means the ability of one object, A, to appear and be used like another type, B. What this really means is, if we go back up here for a second and look at our RoboCop sample, I can treat RoboCop in 3 different ways. I can treat him like a human being, I can treat him like a police officer, or I can treat him like a super deadly, powerful police robot, mashup. So the idea here is that there are 3 different roles that RoboCop can be treated in: as a human, as a police officer, and as a super cybernetic being. So whatever we got here, that's really important. RoboCop is 3 different things: human, police, robot. And that's a good thing. RoboCop is polymorphic because I can treat him in multiple ways. That's all we're talking about, is the ability of an object to be treated in other ways. So let's think about this. We've got this concept of a human, and specifically a human male. So that's a generalization. So you can treat me like a human being, hopefully with good manners, respect, stuff like that, until you, as you get to know me, that kind of like just general gratitude that we give another human being when we meet them. Now, let's talk about a specific human being, Keanu Reeves. Okay? Now, I can treat Keanu Reeves in 2 ways. I can treat him as Keanu Reeves, a human person, a specific human person that maybe you know from different places. And I can treat him like just a general human being. We give very, nice treatment to people through just general manners. And then if I met Keanu Reeves, you might know that Keanu Reeves is, from what I understand, a pretty nice guy in Hollywood. So maybe you would treat him as Keanu Reeves if you were one of his friends. Okay? So what else do we know about Keanu Reeves? He's an actor. Sometimes you treat Keanu Reeves as an actor. When he's working, okay, the director, the people on set treat him as an actor. The media tend to treat him as an actor, right? So Keanu is 3 things so far. He's an actor, he is Keanu Reeves, just himself, and he's a human male. He's also a motorcycle aficionado. Maybe you belong to his motorcycle group, where you go and you talk classic motorcycles with him. So he has another role. Right now we've figured out that Keanu Reeves has multiple roles. He's polymorphic. He can be treated in different ways. And finally, he is Neo. He will save us all from the Matrix, and that really is his fifth role that I've got here to demonstrate. So in this case, right, we've got Keanu Reeves as a human, as just himself, as a specific type of human being, Keanu Reeves, as an actor, that's his job, as a motorcycle aficionado, that's his general hobby, and as Neo, his role that the universe has fated to him to save us all from self-destruction. Could Keanu have other roles? Sure, if he takes a class, he's a student, right? He's obviously the child of someone. There are many roles that people have in terms of life, and these are just many of them. Polymorphic means of many forms, having many roles. Depending on how we see you, you treat them in different ways, okay? Now, how does this idea of polymorphism, of an object being able to be treated in multiple ways, differ from, say, this idea of general association between objects? Well, this is a very specific type when we talk about polymorphism. Like it's a reinforcement of this is a relationship. So Keanu Reeves is a human. Keanu Reeves is an actor. Keanu Reeves is a motorcycle aficionado. Keanu Reeves is Neo. Haha, just kidding, right? Keanu Reeves, I think I said is an actor. He may be, Keanu Reeves is a student at his local college or whatever. To have polymorphism, you need this is a relationship. Remember that association is a general concept between objects. So let's say, for example, I have the Michael Knight object. And I have the KIT, the Knight Industries 2000 object. Well, Michael Knight is not KIT, and KIT is not Michael Knight. You can't say that. There's no inheritance relationship. These are just two objects that work together, and they have a one-to-one relationship. For every one KIT, there is one Michael Knight, and for every one Michael Knight, there is one KIT. And we have a bidirectional association between these two objects because Michael Knight sends messages to KIT, and KIT sends messages to Michael Knight. So this is what an association looks like. This is just a general object sending messages and using another object and to one another. Okay, remember that when we talk about inheritance, it is a much more deeply ingrained relationship. I mean, RoboCop can't be un-RoboCopped, right? Once you learn to be a police officer, you pretty much always have that knowledge embedded in your head. Humans are humans. We can't be unhumanized, hopefully. So these are the concepts. Inheritance is a deeply related concept because you are the concepts that you inherit.